Hello everybody and welcome back to another calculus video. In the last one we talked about some different notation usages and different ways to write out what a derivative is. We talked about the differential form of dy dx, and we talked about how you can just simply write y prime and you'll get the same thing as f prime of x, or even the general differential form of d dx, depending on whether or not it's a y function or an anything function, because if we were to consider this as some letter A, we'll say. That letter A being a general replacement can be dB dx, t dx, anything that we're taking the derivative of with respect to x. Now in this video we're going to be discussing something a little bit more interesting, a little bit cooler. Instead of having to use our really long, boring limit rules and taking derivatives with like the limit as h approaches 0, sorry, not infinity. I'm thinking of something a little bit more complex, of f of x plus h minus f of x over h. Instead of having to use this really long drawn out thing, involves replacing our functions and everything, we're going to learn something called the power rule. And I already had it written up at the top, but we're gonna rewrite that down here again. So we're going to do something called the power rule. And the power rule is very simple. So let's say we have a function f of x equals, if we were to take we want to take the derivative of 3x squared plus 15x x cubed minus 17x plus 5. So you're going to take the derivative of that, and you'd be saying, oh my god, please no, don't make me take the derivative of this. I don't want to take the derivative of that. That's going to take forever. We're going to have to use limits. We're going to have to put an h every single time that there's an x and cube it and just bring out a really crazy polynomial. Well, with the power rule, we don't have to do that. We don't have to do that. It makes our lives so much easier. So let's say if we wanted to take the derivative of it. And the way the power rule works is you take take your power, so we're going to circle that. You take the exponent, which is why it's called the power rule, because it's to a power. And you take the power that the variable is to, multiply it by the coefficient. So you multiply these two guys together. So we get 6, and we keep the x. And then you decrease the exponent by 1 after multiplying. It's very important that after, after multiplying. After multiplying, because if we do it beforehand, we're going to get just a completely incorrect number. So we could just leave that as 6x, and then if we do the same thing, let's multiply 3 times 15. If we take 3 times 15, 3 times 15 is 3 times 5 is 15 plus 45. So we have 45 x, decrease the exponent by 1, x squared minus, and what do you do when it's a 1? Well, basically, if there's no exponent above the x, you can treat that as if it were x to the first power. X to the first power, by multiplying a 1 times 17, you just get 17. And what happens if you decrease the exponent to 0? It becomes x to the 0 power, which is going to be equal to 1. And if that's equal to 1, and you multiply it with a 17, well, you just get a 17 again. Then, finally, if you have just a coefficient by itself, like this lonely 5, there's no x here. There's no x here, so all we have to do is get rid of the 5. Just get rid of the 5. And that's basically what the power rule is. You just multiply all of the powers times the coefficients, then decrease them by 1. And if there is no variable next to a coefficient, you can get rid of that coefficient, and it makes it so much easier. So if we were to take a derivative, let's see here, if we wanted to, let's do it in the differential form this time, because I quite like it, dy dx of, and we want to take a derivative of, let's practice this one more time. So I'm going to go ahead and write down the problem, and I encourage you to pause the video, and after I have finished writing this, try to solve it. And then once you are completed with that, I encourage you to unpause the video and see if your answer matches up with the one that I have written up here. So we'll start with, say, dy. What do we want to take a derivative of? Well, I quite like the function, let's say 14x squared plus 3x cubed minus x squared, and then plus 1. Yeah, pretty complicated polynomial, so go ahead and pause the video, and I'll give you a couple seconds to do that. Alright, and if I assume by now that you've worked through it, and I have unpaused the video, we're going to go ahead and write down what this equals to. 28x plus 9x squared minus 2x, and that's the answer. That is the answer. And the reason I did the tricky part here was something that I didn't go over because I wanted to see if you would be able to just tell by kind of doing it. Is this right here, this little trick. This guy was the tricky one. And he was tricky because, well, we didn't have a coefficient. We didn't have a coefficient in front of our x. We just said, well, we just have an x squared. There's no coefficient here. There's no coefficient right there. Like, what are we going to do with that? Well, there technically is a coefficient there. We just don't bother writing it. It's technically a 1, right? You're just multiplying this value by 1 is what you could say. Because multiplying 1 times anything is going to always give you that same anything. It's not ever going to be any different. So we can treat this as a coefficient 1 and multiply it by 2 to just get that 2x. That right there. And that is the bare bones of the power rule. We'll get into some more things like the chain rule or various other things that make taking derivatives a little bit more complicated. Because right now we're just dealing with simple polynomials, right? We just got a single variable polynomial function, and we don't have to do anything else. We just power rule our way through it, and you could quite literally say we power through it. And we'll get into that here in the next video. Until then, thank you for watching.